Welcome to 20-1s. We're going to do our review sheet here for rational reciprocals. I don't know, probably shouldn't take that long to do. So let's get right at it here. All right, so we got to explain why this rational expression is not defined when x is equal to 2. It seems like a pretty easy thing to do. So if I just were to put the 2 in all the x spots, we're going to see what happens. All right, so I'm going to do a little substitution here. So go 2 plus 2 on the top here. Yeah, that doesn't seem like too much of a problem. You just get a 4 there. All right, so it doesn't seem like that's going to cause too many problems. But then here, if I put a 2 here, so I got 2 squared plus 2 minus 6, what are we going to have? We've got 4 plus 2 minus 6. So 4 plus 2 minus 6, that's 0. Oh, so we get this divide by 0 error, right? So divide by 0 error, right? So can't divide by 0. We talked about this. There's lots of videos on it. We talked about there's a bunch of reasons behind it, but this is undefined. All right. Can't say it's infinity because infinity doesn't really exist. It's just undefined. All right. So let's see what else we have here. So knowing that we can't divide by 0 means it's undefined. We just have to go here. It says to state these non-permissible values. The values, very specifically, the non-permissible values. The values are going to cause this divide by 0 error. So like on this one here, if I put a 0 in there, I get 0 minus 2. And then on the bottom, I get 3 times 0. It's going to be like negative 2 on the top. That's fine. But then I would get a 0 on the bottom. So in this one here, x cannot be 0. Okay, so you don't have to show all that. You just have to kind of just state what would make the bottom equal to 0. All right, so if I look at this one here, I got this 15 on the bottom, but there's no x beside it. So this will always be 15. There's like no matter what I put in there for the x values on the top, the bottom will just be over 15. It'll just be always 15. So here we don't have any non-permissible values. So I'll just be able to say no NPVs, no non-permissible values. Okay. I should put a dot there too. There you go. There's no way to make the bottom equal to 0. Over here, so I'm just worried about the bottom, so I'm not worried about the top. Like over here, I can make the top equal to 0 by putting a 2. I don't know if it clicks so I can't see it, but put a 2 in there. But the bottom will just be a 6. I could divide by 6, that's fine. So we're just worried about what's on the bottom. So usually the way to find this out is just to factor it out. So I'm going to just look at the top here, but I got to figure out what's going to multiply out to negative 6 here. So I'm just going to do my factoring here on the side. So what multiplies out to negative 6 because of the 2, right? So go 2 times 3 and adds to negative 1. So we've got 3 and 2. That's my, negative 3, positive 2. And because of the 2, I'm going to have to use that in my factoring. So I use my negative 3, my 2, but I put a 2 in those 2 spots. And then I'll just reduce these down when I go over here. So remember, this is like my intermediate step. So this is just on the side somewhere. All right. So, and then after that, over here, we got 2x minus 3. I can't reduce that down. Just like the fraction 2 over 3, you can't do anything with it. On this one, I could divide them both by 2. So I get x plus 1. All right, so if I look at this carefully, just make sure we factored it correctly. You might do this a couple times, but you look at this, say 2x times x. That'll give me my 2x squared, which is awesome. Negative 3 times 1 gives me my negative 3. We just kind of hope everything else works out. Now, looking at this, I can figure out what would make the bottom equal to 0. So I got 3 over 2 and negative 1. And there you go. I'll put my answers around, or boxes of my answers here. So this here's just a side note, right? Okay. Yeah, so not too bad. Let's see what we have here. Okay, here we want to simplify each of these expressions. This one looks very similar to the one we just did, but has a negative 5 instead of a negative 1 here. You'll see how that's going to change the question. So when you're simplifying, even though it doesn't say determine your non-permissible values, always do that, right? That's part of your simplification. You got to make sure the original equation is the same as the last equation as well. So they both have to be equal to each other. Okay? So I'm going to try to factor this one out. Let me just change my color back to what it was before. So the top here, I can't really factor anything. All right, so the bottom here, I'm going to try to factor that bottom piece. So again, I'm going to do my factoring over here on the side. So what multiplies out to -6 and adds a -5? So that would be like a -6 plus 1 this time. All right. So I'm going to, oh, maybe not there right away. I'm going to go 2x minus 6, bracket, bracket. And then over here, I'm going to go 2x plus 1. So I reduce them down if I can. So the first one there I can divide by 2, so I will. And the second one I can't do anything with. All right. So maybe before I cross them off, let's just talk about a non-permissible value. So we got 3 and -0.5. And then I go over here and I say, oh, I can cross those two off because they're the same. And my final answer is going to have an x minus 3 on the bottom. But on the top here, remember when you cross these off, you don't really write it. But in this case, you probably should. It ends up being a 1. So you got a 1 on the top. I guess you don't have to put brackets around the 1. All right, so you just write the 1 there. And then put a box around my answer. I kind of put the non-permissible values in a weird spot there. Cool. So that's pretty much how you simplify them. You just factor the tops, you factor the bottoms. If any factors are the same, you cross them off. And there you go. All right, so the next one, we're going to multiply these. Now, multiplying is the same as, oh, that was kind of weird. Multiplying is the same as pretty much just simplifying these ones over here. You just factor the tops, you factor the bottoms, and you can cross off anything that's on the top with anything on the bottom. All right, it doesn't matter if it's on either side of this time sign here. That's just kind of like an extension across the vinculum there. So let's factor the top over here. That doesn't seem too bad, so I'll just put a bracket, 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 bracket. X times x, what multiplies out to 12, -12, and adds to -1, so that's probably -4 and +3, probably. The bottom here, I'll just factor a 3 out of that, so I get x minus 5. Okay, always look for those GCS before you're factoring. The same thing here, I'm going to factor maybe 12 out of both those. Just double check here. Just got my calculator for a reason. Yeah, I can divide them both by 12. I don't. Yeah, I can't. Oh, I can divide by 24. What was I thinking? All right, so let's divide them both by 24. So let's factor that 24 out. So I get x minus 3 here. And on the bottom, oh, that's the difference of squares because 9 is a perfect square. So x times x, and then -3 plus 3. So you can see that I kind of just got rid of the time sign because it doesn't really matter in this case. Maybe before I start crossing things off, let's think of our non-permissible values here. So I'm just going to write them right here. It's probably going to hopefully be beside my answer. So we got 5, 3, and -3. That's because of these two here, but this 3 in the front, just like that 15 before, it's just going to be a 3. There's no way to really change it to a 0 unless I multiply it with a 0, which is one of these other guys here. All right. Remember, you don't care about the top, so there's 4 I don't care about. Okay, so let's cross some stuff off here. So we got x plus 3s, we've got x minus 3s, and here I can reduce this down. So this 24 divided by 3, I can reduce that down, divide them both by 3, and I'm going to end up with an 8 here. All right. So what do we have on the top? Let's make sure it stays on the top here. So I got an 8 here in the top, then I got x minus 4, and the bottom, I got x minus 5. Cool. So let's put a little bracket around that. A little box. And there's my answer. All right, looking pretty good so far. I give you guys lots of space for these. Didn't I? Yeah, it seems like I did. Oh, none of these. There's a times there. I don't know why there's a times here all of a sudden. Is there a divide anywhere? Oh, I didn't put a divide here. There'll be a divide on the test. Just make sure that if there was a divide sign there, you flip and you multiply. It's really not much different than anything else we've done so far. Yeah, I'm surprised I didn't put a divide on this sheet for you. We've done nothing. All right, so in this next one, let's factor this out. So it looks like I'm just going to factor out a I don't know if I can do anything with this. It's not even a difference of squares or anything. I think that's, let me just double check here. Sometimes you just factor out, it doesn't really do anything. So this one here, 2 bracket x squared plus 9. All right, and the bottom here, we got x plus 3, we got x minus 3. There's nothing else you could do. Like, I don't see anything you can cross off here. The bottom is not a difference of squares. Can't factor out. There's no minus sign up there. So this looks like my final answer. And just put my non-permissible values. So x can't be plus or minus 3. And I'm done. Maybe that's a typo. Maybe I should fix that question for next year. Maybe make it have a minus sign in it so you can actually factor it. And probably make one of these a divide as well. Maybe like this one down here. Yeah, put a divide on one of these. That'll be next year. Okay, let's keep on going here. Yeah, so far we're doing pretty good. Now we're going to add, subtract here. And there's another multiplication one here. So, yeah, we'll just come back to them. I was thinking of just doing the multiplication one first, but let's come back to that one later. So I'm going to move my head here for a second. Just put myself over here. Okay, so when we're adding and subtracting, we just got to make sure our denominators are the same. So when I'm looking at this, I notice my denominators are not the same. Because they're not the same, I'm going to factor them. If they are the same already, just add or subtract the tops and you're done. Maybe factor and cross things off like a regular simplification question, like that first one. All right, so once you get here, factor and see if anything reduces out. All right. So we're going to have to get to the point where it's just one single vinculum here. So we're going to factor the bottoms of both of these. X, a 2 and a 1. So the only thing that multiplies out to a 2. It's going to add to 2, or sorry, multiply to 2 and add to a 3. So they both have to be positive. And then I'll factor out the other one over here. I'll put brackets around the top. Actually, I probably should give myself a little bit more space here. All right, I don't know. That might be a bit better there. Just delete that there. Because I may want to add in something into the denominator here. So I'm just going to give myself a little bit of space. So I'll factor the bottom of this one here. Let's see what we have. We got x and x. Okay, what multiplies that to 4 and adds to 5? So that'd be a 1 and a 4. Okay, so I'm looking at these right now, and they have a common denominator, or at least one common factor. So they have these two are in common. I don't know why that's so big. Let me just fix that. Someone's fiddling with my highlighter. So these are right now in common. So because they're in common, I don't have to deal with them. I don't want to change them. They're already there. We're looking for a common denominator. If they already have one thing in common, don't change it. But you notice that one has an x plus 2 and the other one has an x plus 4. So there's a difference there. So you've got to make sure they're the same. So I'm going to include the x plus 4 here. Okay, and I'm going to include the x plus 2 on this one over here. Now, very common at this point is just hey, let's just cross these off because they're the same on top and bottom. But then what's the point? Right? If you cross them off, you can't add or subtract them anymore. So you want to try to keep the denominators the same so I can add or subtract them. So I can't cross things off now because then the denominators won't be the same. So I got to keep the bottoms there, don't cross anything off. But what we have to do is we have to use our little rainbow method here and distribute these two things into each other. All right? So the first one here ends up being x squared plus 4x. And I'm going to have a minus here. I'm going to put big brackets around this. All right? And this is all going to be over top of my common denominator, my x plus 1, my x plus 2, and my x plus 4. All right? Then I do the rainbow on the other one over here, but you notice I put that in brackets because there's that minus sign. You have to minus everything that's going to be on the top here, so I'm going to be very careful about what I'm minusing here. So I'm going to have x squared plus 2x minus 2x. I was kind of given because these are conjugates. Remember when you multiply conjugates, the middle term kind of cancels itself out. And then I got negative 2 times 2 is negative 4. So you get this kind of difference of squares here. So let me just kind of clean up what's inside the brackets there. So I'm going to have x squared minus x squared. Oh, okay, that's kind of nice. X squared minus x squared is gone. And then I have x squared minus a negative, or sorry, 4x minus a negative 4, but that doesn't have x, so they can't group together. But so I have 4x plus 4 on the top here. And the bottom, I'll just have x minus 1, or x plus 1, sorry, x plus 2, x plus 4. Okay, so now we kind of group them together. Now, just like a simplification question, like in a previous page here, we just want to see if we can factor the tops, factor the bottom. With the bottom's already factored, so that's great. Factor the top to see if anything's going to reduce out. So if I factor the common out, the common GCF there, I'm going to be left with an x plus 1. And you can see that the x plus 1s are going to cross off. So I'm left with my final answer, 4 over x plus 2, x plus 4. All right, non-permissible values, negative 2, negative 4, and negative 1. All right, negative 1. Just be very careful about the ones you cross off. They still have to be included because they were non-permissible values of the original question. So they have to be non-permissible values of our last part as well. Yeah, not too bad there. Let me move my head. All right, so this next one, this seems like an easier question. I don't know why I had to worry about this one. Yeah, it doesn't matter. So right now I know a can't be 0. The denominators are not the same. You just have to figure out how to make them the same. This probably should be done first here. Yeah, if I just times this other side by 2, I can get 4a. And that means that to just times the top by 2, just like we times the top and bottom of the other ones. All right, so I get 10 plus 3. In the bottom I have 4a. And then I have here 13 over 4a. Okay, that was a pretty simple question. There we go. Okay, let's move on to a harder question here. So let's go over to this question here. All right, so what I'm going to do, just like the previous one, factor the bottoms, maybe factor the tops to make our lives easier. Sometimes if you factor the tops and the bottoms beforehand, something might reduce out. Maybe not. Who knows? So let's see what happens. Okay, can't factor the top. So I'm just going to rewrite the top. Or rewrite the top here. But I can factor the bottom, so I'll just divide everything by 3. Pull my calculator out because I'm too lazy. It's too late. So what is it? Almost 10 p.m. here. Whoa, that's late. Yeah, so let's divide out the 3. All right. Then on the other side, I'm going to divide out my 8 as well. So 8 here, x plus 9. And then the top, I can't factor the top. Plus, yeah, it doesn't really do anything either. So I'm going to put that in brackets. I'm going to put this one in brackets too. Okay. So right now I have a common denominator, x plus 9. So they both have an x plus 9 in common. So the only thing I need to do is add in what's not in common. So there's an 8 here, there's a 3. So I want a 3 on this one, so I'll just put a 3 over here. And over here, I want an 8 on this one. So I'll times the top and bottom by 8. All right. So that, yes, gives me a 24 on the bottom for both sides. So I'll have a 24x plus 9. So you notice when I'm adding and subtracting, the denominators stay there. When I'm solving, I want to get rid of the denominators. I want to move the x's to the numerator. But when I'm just kind of simplifying and adding and subtracting, the denominators stay. At the top here, we got 8 times 8 is 64. So 64x. And here I'm going to times that 3 in. Oop, I got this bracket here, so I'm going to worry about this bracket in a second here. So I'm just going to times the 3 in. I'll leave the negative there. Okay, so that gives us 18x minus 15. Yeah, seems right. So I'll simplify the top just a little bit more. So this minus here, because I am minusing this other one over here, it's going to have to apply to both these. So I'm going to have a technically plus 15 there. So 64x minus 18x is 46x plus 15 all over 24 bracket x plus 9. Let's see if I can simplify this down a little bit. So 26 is not divisible by 3. And it's not divisible by 5. So okay, I can't do anything. There's my partial full answer. Remember, you always got to do those non-permissible values. There we go. Cool. Yeah. Cool. All right, sorry about that. I just had to pop away for a second. So let's get back at it here. What else do we do here? So let's just change this up. So let's, maybe I should be this guy. A little baby elf. Is that going to freak anyone out? Okay, so let's try this out. Yeah. Cool. All right, so just like any other question, we're going to want to factor the tops and the bottoms here. Let me just So I'm going to factor out what's in common. So it looks like we're just going to factor a 2 out of this one. So I'm going to factor a 2 out, and I'm going to get 4x squared minus 3. Doesn't seem like it's going to help me out. Like that. And then over here, I'm going to multiply that with this one. So if I factor out a 3, we have 4x squared minus 3 as well. All right, and on the top here, I'm going to factor a 2 out. So there's the time sign here. So 2, so there's a time sign, so this is different than adding subtracting, right? So you want to factor all the tops and bottoms and see if anything crosses off. So factor the 2 out. Okay, let me see if we could factor any more. So we got 4x squared minus 3. On the bottom here, you get x minus 4. And then over here, this one doesn't factor. 4x squared minus 3 is not a difference of squares because the 3 is not a perfect square. Uh-oh, I broke it. Yeah, I broke my computer. Okay, so it seems like that baby elf face kind of broke it. So I'm going to restart here. So hopefully you caught most of that. I don't know when it broke. So we're going to factor the top here. So when I factor the top out, because it is a difference of squares, so 16 is a perfect square, and this is a minus sign, and this is squared. But because the x is second, my x is going to be second down here, unless I slightly modified the question by factoring something else out. But I'm just going to keep it the way it is. So I'm going to have, since the 16 is first, I'm going to have 4 and 4 here. And to get the negative x squared, one of these is going to be negative, one's going to be positive. Okay. So now when I start crossing things off, these two factors are the same. They're kind of weird, they're big factors, but they are exactly the same. So I can still cross them off. And then we've got to remember about opposites. So this is positive x minus 4, and this is 4 minus x, positive 4. So those two are opposites, but because they're opposites, it's going to leave behind a negative 1. All right, so now there's this negative 1 here. Anything else that's going to cross off? Let's see, we've got a 2 and a 2 and a 3. No, nothing there. No other factors cross off. Okay, so on the top, I got 2 times 2 times this negative 1. So I got negative 4, and then I got the 4 plus x still left over. And the bottom, just have a 3. Then I'm going to worry about a non-permissible values. So we have a non-permissible value of 4. Then we got some weird ones here. So this one here gets a little bit tricky to do. So we could still solve for x here, because something is going to make this equal to 0. So I'm just like a little side note here. So I don't want this piece, this bottom piece, to be 0. All right, so I'm just going to write it out as if it's, oh, I don't want it to be 0. And then start rearranging like a regular equation. So I don't want 4x squared to be a 3, because if 4x squared was a 3, 3 minus 3 would be 0. Okay, so I start rearranging this around. Then I divide by 4. And then I'm going to take the square root. So I'm going to go, I'm going to take the square root of both sides here, square root. And because I took the square root, it's going to be plus or minus the square root of 3 over 4. And you could simplify that down, like this could be plus or minus, because when you take the square root of a fraction, you just take the square root of the top, you take the square root of the bottom. So the square root of 3 over 2, because the square root of 4 is just 2. So either or doesn't really matter to me at this point. But we have 2 more answers that are going to cause some problems down there. All right, that's a weird one. But we still get those non-permissible values. What do we have, 25 minutes? I thought it was going to be a bit faster. All right. Oh yeah, we got quite a bit, and then we got to draw the rational expressions, or reciprocals there. That's fine. We'll take our time. All right. We're going to solve these. Okay, so now these ones are a little bit different than what we did previously here. So these ones are simplifying. We're combining them together, getting into one vinculum, canceling things off, worrying about a non-permissible values. But when it comes to solving, we need to figure out what x value would make one side equal to the other side. There is actually one x value. In all these simplifying ones, there's no x value. It just be whatever you want as long as it's not one of those non-permissible values. So if I want to solve this one, I need to get rid of all these denominators where the x is in the denominator, because I want to solve for x. You can't solve for x while it's in the denominator. So I need to figure out a way to get rid of them. So the first thing you probably want to do is factor the bottoms, because you don't want to accidentally multiply by too much. You kind of want to multiply by the minimum amount to simplify the question down as much as possible. So on this one, because we do have an equal sign, we're allowed to do this. We can times both sides by x minus 2, x minus 2. So this one's going to cross off here. That's awesome. And then we're going to times both sides by 2x minus 1, and then over here 2x minus 1. So we're just timesing the tops there, but then those cross off. So what's left over is I have x minus 2 times 3 on this side, and then 2 times 2x minus 1 on this side. Okay, now I still want to solve for x, but you notice I have no more denominators, so that's great. That's our goal. So I'm going to times the 3 in here. So I get 3x minus 6 there, and then over here I got 4x times the 2 in minus 2. And you're going to manipulate this around. There's no square, so that's good. If there's a square, make it equal 0, factor it. Because there's no square, just rearrange this to solve for x. So what I'm going to do is I'm going to minus the 3x over to this side over here. All right, so I minus it over, so I just get x. 4x minus 3x is 1x. And then I'm going to add the 2 over to this side. So I get negative 4. So it looks like x is equal to negative 4. Now, assuming that we did everything correct, and as long as this is not a non-permissible value, the answer should be okay. Now, my non-permissible values, let's double check. X cannot be 2.5. So it's not one of those. Hopefully we did it correctly. If you want to, you can go back and verify them, put the negative 4 in all the x spots, see if it works. Hopefully it does. All right, so we're going to try to do the same thing for this next one. We need to get rid of all these denominators. Now remember, everything with a vinculum here is its own individual term. So there's a term there, there's a term here. This 8 is its own term as well, and that's a term. So when I multiply everything by 3, I have to multiply all 4 of these pieces by 3, because I need to get rid of this 3 here. If I multiply it by 6, I've done too much already. All right. If I multiply by 6, it covers the 3's as well. But usually what I want to do is, like, you want to factor the bottom. So I notice that the 6 is actually just 2 times 3 times x. So multiplying by everything by 3 and 2 should cover that. And x should get rid of all that. Okay, let's see what happens when I try that. So I'm going to multiply this one. That should be x there. I'm going to multiply it by 2, 3, and x. All right, those are the, seems like that's everything I need. So get rid of the 3, get rid of the 2, and get rid of the x. All right, okay, let's see. I'm going to put a 3 in the bottom of this one. Then I'm going to multiply this 8 here by a 2, a 3, and an x. Then I got to multiply this 1 here by a 2, a 3, and an x, but it was all over 6x already. And then over here, I'm going to multiply, this is getting a bit tight here, 2, 3, and an x. Let's divide this all by 3. Okay, let's see what crosses off. So the 3's cross off here, nothing crosses off there. The x crosses off here, and the 6 crosses off with the 2's and 3's. So essentially that just leaves me a 1 there. That's awesome. So it is a 1, not nothing. There's a 1 there, right? Cross the 3's off here. Okay. Let's see what we have. So we have 2 times x. So I have 4x and then 1 minus x still. Over here, I have 6 times 4, or 6 times 8, sorry. I turn my calculator on. So I have 48. X, there's a minus sign still there. Everything crossed off except for the 1 there, so I'll leave the 1. And then minus, I have 2x minus 3. So that's what we have so far, and you notice there's no more denominators, so that's awesome. And then I'm going to multiply the stuff into the brackets, and just like the previous one, try to solve for x. All right, so let's multiply this in. I'm going to get 4x minus 4x squared. Okay, got a square. Maybe I'm going to make this equal to 0. Let's see what happens. And over here, I'm going to multiply this. I'm going to include the negative as well, so I'm going to multiply that in, just like when I multiplied this one in. But I'm going to include the negative as well, so I'm going to get negative 4x squared. Negative, there's 2 negatives here, so this is going to be positive 6x. So if I added over the 4x squared to this side, or either side, they're going to cancel out. If I were to add them to each other, they're gone. Cool. So if I group my like terms together on this side, 4x minus 48x, that's probably negative 44x on that side. Here we got 1 plus 6x. Okay, so I had to solve for x here. Let's see, I'm going to solve for x. Let's see, I'm going to add over the 44 to this side. 1 plus 50x. And then I'm going to solve for x by minusing the 1. I know it's kind of a strange way to do this. I could have just subtracted over here and divided by 50. Negative 50. But we do get negative 1 over 50 as an answer. It's a weird answer. It's not one of my non-permissible values. Actually, I only have 1 up here. X cannot be 0. So if we did this correctly, hopefully it's right. Now there is a way to check. You just graph this in your calculator, see if it works, or just put that number back in there, right? I don't have my calculator out at this moment, so I can't really show if it actually does work. Hopefully it does. Oh, my calculator's loading up here. So I'm just going to show you what it looks like if you try to verify this on your calculator. It's going to just take a bit of time here. Where'd it go? Disappeared on me. Well, yeah, I kind of lost my calculator for some reason. Actually, my pen's not working. Oh, I was thinking about it. There it is. There it is. Okay. I have some weird graphs from a different course here. Or same course. It's just the reciprocals. So let me just clear this out of here. Actually, I don't have to worry about that at all. So what I'm going to do is I'm going to put negative 1 over 50 into my x spots. Remember, you can use the STO, put a little x there. So this way I don't have to keep on typing negative 1 over 50 each time. And then what I'm going to do is I'm going to start typing out the equation on the left side. I'm going to hit enter. I'm going to type the equation on the right side and hit enter and see what happens. So the equation on the left side is 2 bracket 1 minus x bracket over 3 minus 8. Minus 8. So if you hit the fraction button, it makes this a lot easier. Hit enter. So I get this weird fraction here. I just want to make sure the other side ends up being that weird fraction. If you get a decimal, make sure it's the same decimal. All right, so if you want to see what that is, a decimal, you could go math, change it to a decimal. So it's negative 7.32. Okay, so on the other side, I'm going to do the same thing. Now this is what it would look like if I didn't use my fraction button. So you got to make sure to use these brackets, right? Minus, and I got to go bracket 2 minus, or 2x minus 3, bracket divided by 3. If I hit enter, they're both the same. So we did something correctly. Sweet. I was kind of doubting myself with that answer. Well, there's a bunch of elephants there. So let's get this back here. So through some verification, this answer actually is true. If we trusted our work, and we hopefully did everything correctly, it should have been true because it wasn't a non-permissive value, but I just didn't trust my work for some reason. But it seemed to have worked. Awesome. Okay, so let's see if we can solve this next one here. Now, just like the previous one, not this one, but this one over here, sometimes it's easier to factor before you start the question. So definitely going to be easier to factor this or start by factoring it. So x minus 1. I'm going to leave myself a little bit of space here. And then over here, because I want to multiply the top of this one by something. And then over here, minus 12. And then the bottom, I'm going to factor x minus 1, x plus 1. All right? And then over here, I'm going to leave myself a little bit of space as well. Now, I need to get rid of these denominators. But remember, you're trying to do as minimum work as possible. So if I multiply by x minus 1, and x minus 1, and x minus 1, that actually covers all the x minus 1s right away. So I don't have to multiply by x minus 1 again to get rid of both of them. You just have to do it once. But I still have to get rid of this x plus 1. So x plus 1, x plus 1, and then over here, x plus 1. So what do we get here? We got 5 times x plus 1, no more denominator, minus 12 times x. Oh, this one crossed off. I should have crossed that one off. So not times in by anything. And then over here, let's just multiply that out. We got x squared minus 1. All right, so remember when you do the distributive property here, you got to do all 4 terms. X times x, x times 1, sorry. Then negative 1x, 1x minus 1x. Well, that's 0 x's. So that's why there's no third term here. And then negative 1 times 1 is negative 1. So you do it all. It does simplify down because those are conjugates. Times the 1, it doesn't really do too much. So you get 5x plus 5 minus 12 is equal to x squared minus 1. Make it equal to 0. What do we have here? We've got negative 1. I'm going to add over the 12 minus the 5. Delete. Enter. So I get a 6 here. Positive 6. All right, so it's equal to 0. Factor it out. Remember, we're making this equal to 0 because there's a square in it. The square didn't disappear like the previous 2 up there. So we just have to make sure it's equal to 0 and factor it out. It's pretty much the only way you can solve these quadratics. So I need to figure out a way to multiply to a positive 6 and add to a negative. So that looks like it's going to be my answers. We got 3 and 2. Now, neither one of those answers is my non-permissible value. Because up here I have x cannot be 1 and negative 1. You can see down here, that's what they were. Cool. I'm going to trust that it worked. Hopefully, you can go back and verify it. I hope that's true. This one looks ugly. Yeah, okay, let's do it anyway. It's good practice. Make sure you're not making any mistakes. So I don't have to factor anything in the bottom. Nothing crosses off right away. Let's just go at it. So it's going to be a bit big, so I'm going to have to give myself a bit of space here, or write small. Okay, so I got 6, 2x plus 1, oops, x plus 3, 2x plus 1. So I'm just going to rewrite the whole question here, but just giving myself some space to do some multiplying here. You notice I'm just adding in brackets where it seems appropriate. And then we start multiplying in things. So I want to get rid of this 2x plus 1, so I'm going to times by 2x plus 1, oops, plus 1, to absolutely everything here. So everything that has a vinculum is its own term, 2x plus 1. So let's cross them off, so I don't accidentally times them by 2 times, so that gets rid of those, and then I'll do it again with the x plus 3, so that one crosses that off, x plus 3, and then over here x plus 3. Oh man, you have to get rid of the 6 as well. So I'm going to times everything by 6. So this cancels that 6 out there, but I got to make sure it times this by 6, this one by 6, and this one by 6. Oh, that's a lot of stuff there. U is going to be pretty big. So what do we have? I'm going to put the 6 first here. So 2x minus 1 times x plus 3, that's my first term. Plus, I'm going to put the 6 in the front of this one too. X plus 1 times 2x plus 1 is equal to, I'll put that 6 in the front as well, so 3x minus 1, x plus 3, and this one doesn't have a 6 crossed off, so I just have 2x plus 1 and x plus 3. Okay, it's going to be pretty ugly, so I'm going to multiply this all out. Didn't we do this question already? I think we did. This looks like a very familiar question. Very ugly question, but I think we did this one. Lots of stuff here, lots of things are going to cancel out. I almost don't want to do this question again. Might as well do it again. Why not? All right, so I'm going to multiply out what's inside the brackets here. So I get 2x squared. What else do we have here? 6x minus 1x, that's 5x. Minus 3. Yeah, I remember this one having a lot of places where you could make mistakes. And I already see it. 1x plus 2x is 3x. And then this is plus 1 here. And then I'm going to do the same thing here. So I got 3x squared. So what do we get? 9x minus 1x. So that's 8x. Seems right. Minus 3. And then here we'll just get 2x squared. So 6x plus 1x is 7x, and then plus 3. So you notice that one doesn't need brackets because we don't have a 6 in front of that one, but these ones you have to multiply the 6 in. So you get 12x squared plus 30x minus 18 plus 12x squared plus 18x plus 6, and then 18x plus, oh man, I lost my math here, 48x's, is that right? 48, yeah, 48x's. Yeah, this sounds very familiar. We've done this question before in class, but always fun to do again. So we're going to start rearranging things. You notice there is an x squared, so if I start moving things around, I want to make everything equal to 0. So I'm going to move everything to the left here because I see I have more x squareds than anything else. So I'm going to minus over the 18x squared. I'm going to get 6x squared, okay, because I got 12x squared plus 12x squared minus over that one, okay. Then I got the x's, I got 30x squared plus 18x minus the 48x and also minus the 7. So I get negative 7x. So it's simplifying down really nicely. And we just have to worry about the non-x's, so I got negative 18 plus 6 on the left side. And then we're going to add over the 18 and minus the 3. So I get just a positive 3 here. Okay. All right. So what do we get here? 8 times 3 is 18. So 9 and 2 would get me the numbers I want here, would it? No, it wouldn't. Would it? Would it? Yeah, it would. 9 and... No. Now I'm confused now. Did I mess up on my numbers? 9 and 2. No. What am I messing up on? So I got to multiply it to a positive 18. Did I use the quadratic formula? I hope not. Seems like I almost want to go back to my notes and figure out what the answer would be for this one. Did we do this one previously? And one of these other ones? Let's get past the bootleg Allen there. That's more reciprocal stuff. Here, is this the one? No, this is just a different question altogether. Oh, here we go. Is this the one? No, seems weird. I don't think it's in the notes either. What's bootleg Allen doing here? Ah, it's scary. You know, they're just kind of looking at me, just kind of flipping around here, trying to find out where this answer is. And maybe I'll just pause this first. Okay, I'm back. Yeah, so one thing, there's a lot of things that can go wrong here. One thing I forgot about this question is this 2x here. I forgot to minus that over. So this actually ends up being a 4 here. Makes the question a little bit more solvable now. Okay, because that's a 4, I'm going to have to do some factoring here. What multiplies out to 12 and adds to -7. So that's going to be a -4 and -3. So we got 4x minus 4. And then we have 4x minus 3. So when I factor this out, remember this is just a little side note here. This is just a factoring method, right? We still have to reduce this down. So we got x minus 1 and 4x minus 3. What would make that equal to 0? So it looks like 1 and 3/4. All right, so there we go. A lot of things that can go wrong. That's a big question. Don't expect that on the test. All right. Let's try out one of these here. So an average speed of a plane is 8 times faster than the speed of plane is 8 times faster than the speed of a train. To travel 1,200 kilometers, the train requires 14 hours more than the airplane. Okay. Determine the average speed of the train and the airplane. I got to find the two speeds. All right, so I'm going to create a little chart here. Just like any other chart. So this is my v is equal to d over t stuff. And hopefully it's going to create some kind of rational expression for me to solve. All right, so I got my velocity here, my first column, my d in this column. Doesn't matter which column is which, honestly. I always like to go v dt when I do this. All right, we got two things here. We got the train, and then we got the plane. Okay, so the plane is 8 times fast, 8 times as fast. So as the plane or the train is slower, so that means the plane is 8x and the train is x. All right, so the plane is 8 times faster than whatever the train happens to be. We've got to find out what x is here. I know they're both traveling 1,200 kilometers here, but the train requires 14 more hours than the airplane. So it's going to be maybe a subtraction question. So if I could find out what this number, so like maybe not like a total, but there's going to be like a minus. It's not like you're adding them to get 14, but one's more than the other. So if you minus the two numbers, you should get 14. Does that make sense? Or maybe you can like add 14 to one of the sides to make sure they balance out. You could try to do that too. I'm going to go with a subtraction question here. So if I rearrange this for t, because that's most likely what we do here, we go d divided by v, so times the t up, divide the v back down. Yeah, so you get 1,200 divided by x, and then here I get 1,200 divided by 8x. And if I minus these two rows, if I minus them, it should equal 14, because one is 14 more than the other. So if I take the train number, which is slower, I'll just write it down here because there were lots of space down here, and I minus the airplane, which is faster, I should get 14 hours because one's 14 hours more than the other. All right, so let's see what we can do. So what is, maybe I can simplify the question down. We did one of these in our notes where if you could just divide the numbers, why not? So here I got, this one I can't do anything because there's a 1 here, but here I can divide the 1200 by 8 and get 150 over x. That's right, 1200 divided by 8, yeah. So that gets rid of the 8, so I don't have to times everything by 8. I can just reduce it out first. Makes my life a little bit easier. But I still have to solve for x, so I'm going to multiply everything by x here. So I'm going to multiply this by x. I'm going to multiply this one by x. And I'm going to multiply this one by x. By multiplying by x, the x's cancel out on this side, and I'm left with 1200 minus 150 is equal to 14x. Yeah, that's a simple question. 1200 minus the 150, I'm going to get 1050 is equal to 14x here. And I'm going to just divide by 14. So 75. Ah, it said 75 and then I wrote 17. 75. Okay, so I'm just going to go back and just double check my units. So the distance is in kilometers, the time is in hours, so this is going to be kilometers per hour. That's how fast the train is moving. So on the side here, I'm just going to write down a little bit of paraphrasing. So my train travels 75 kilometers per hour, and my airplane travels 8 times that. So it's going to travel 600 kilometers per hour. There we go. Looking good. Yeah. Okay, this word question is a bit tricky. So the next one here, we got 2 graphs here. Oh, we're reaching an hour point. All right. 2 graphs. We want to graph the reciprocals. So clearly showing all the asymptotes and the invariant points, and then maybe some other key points. Like this is 5. Like remember, when taking the reciprocals, you're always taking the reciprocal of the y values. Let's just imagine, let's do the key ones first. Like here, 0. If my y value is equal to 0, 1 over 0 is undefined. So I'm going to have an asymptote at this line right here. So I'm just going to draw a dotted line for that. All right, so that's one way to clearly indicate the asymptote. Maybe I'll actually write the word asymptote here. I can actually clearly indicate that this is actually a vertical line at 10. So I could say x is equal to 10 for this one. Sometimes it's harder to represent what they are, but this one's easier. And then let's look for some other key points, like, when my y is equal to 1, so they're right here, right at this point, that's going to be an invariant point. So I'm going to just put a little IP here. And then when my y is equal to -1, all the way across here, I'm going to have another invariant point right there. Okay. So I got 2 invariant points, so my new graph is going to have to go through those 2 points as well. And then I can find some additional points. Like this point here looks like it's a half. So the reciprocal of half is 2. Then if I want to go down a little bit more, like right about there, it looks like about a quarter. And that's going to be 4. I could do the same thing on this side. -2, or sorry, -1/2 turns to a -2. -quarter turns to a -4. Okay, so we got this graph that's kind of doing this. Ooh, that's not very nice. On this side, and this one here is going to go down on that side. All right, and then as it goes the other direction, the y value is getting larger and larger and larger and larger, going up the graph backwards here. So 1 over a larger number is going to get closer and closer to 0, but never quite get there. So like here, this is value of y is equal to 2, so I'm going to go down here and get a half. This is let's go up here, 4, so that's going to be a quarter. And then it's just going to get closer and closer to 0. So let's try our best not to cross the x-axis there. And then I'm going to draw the same thing on this side. A couple of extra points here. Quarter right about there. Okay. Perfect. And that's it. There's really not much else to do. I guess you could indicate that this point right here is 1 over 5. Like my y value is 1 over 5. That's my new y-intercept. But we don't have any x-intercepts. We have a new y-intercept. That's good. All right, so let's see what this one looks like. So I'm looking at this graph. I purposely did this to this graph because there is no asymptote here. Remember, the asymptote happens when the y value is equal to 0. But the y value, this graph never crosses the x-axis, so there's no y value is equal to 0. So we don't have any asymptotes. Okay, but we do have invariant points. Remember when y is equal to 1? Oh, we only have 1 right here. The minimum point happens to be my invariant point. Okay, but I can find some additional points here. So like here, the y value is 2, so I just go straight down from there, put a half here. Same thing over here, go straight down, put a half here. This is 3, so I have to draw like a third. I know that's a bit weird to do. You do the same thing here, a third right there. Here's a 4, so that's going to turn to a quarter. Right about there. That's going to turn to a, where's that 4 over here? Is that 4 right there? Yeah, it's going to turn to a quarter right about there. Okay. So this graph going. So as it goes outwards in both directions, it's getting closer and closer to 0. But then it's going to kind of bulge upwards here. I think this is what the graph's going to look like. I may have to look at my graphing calculator and see whether or not that's what I think that's what it's going to do. It's kind of looks a bit lopsided here because it's what I did on this side over here. So I'm just going to kind of redraw that. Okay, oh yeah, so I forgot to label my asymptote, my horizontal asymptotes. So I got a horizontal asymptote here, I got a horizontal asymptote at y is equal to 0 on both sides here. All right, I probably should go back and do that for these ones here too. So y is equal to 0, my horizontal asymptote, and another one at y is equal to 0 here. So these little dotted lines indicate that for me. I kind of want to see what this graph is. If this is true, is that what that's going to look like? So what I'm going to do is I'm going to pull up my graphing calculator. I'm going to kind of create an equation that represents this. I'm not going to be too accurate about it, but I'm going to put in that a bracket x minus p form into my graphing calculator here. I'm just going to kind of guess what the a value was, though I did create this question, so I think it was a half or a quarter. I can't remember now. Maybe I put it as a half. But I know my vertex there is at 4 and 1. So I can do the P and the Q pretty fast here. So let's imagine that this is what the graph was right here. And what I want to do is I want to see what the reciprocal of it. Let's see, it's a little bit high. Oh no, maybe about right. Okay, it looks pretty good. And I want to do the reciprocal of it. There are quicker ways to do this. So what I'm going to do here is I'm going to go 1 divided by, and I'm going to put it over y1, like that. So that's going to do the reciprocal of y1. Let's see what that graph looks like. Oh yeah, that's kind of what I drew. A little bump there. Yeah, I can see it. Yeah, looking pretty good. But you notice there's no asymptotes, or no vertical asymptotes. There is a horizontal asymptote here on both sides, but no vertical asymptotes there. Sweet. And this would be 1/9 down here now. There you go. Cool. All right. I'll put a PDF of this online, and I will see you all on Wednesday. If you have any questions, send me an email. I'm sure I can answer back pretty fast. All right. I'll see you then. Bye.